Welcome to today's concept interference. Interference means modification of intensity due to the superposition of the waves. First of all, we have to know some basics about our first unit, that is interference and diffraction. Regarding that, I would like to recall some fundamentals related to the wave nature and the characteristics or properties also. First of all, wave. The disturbance created in the media is called as wave. Disturbance created in the medium is called as wave. For example, if you take a bucket of water, initially the bucket of water is at the rest. The bucket of water is in the rest. This is the water. Initially, it is totally in the rest. Suppose if you drop a pebble or stone, what we can observe? Yes, exactly. We can observe ripples like that. That means from the equilibrium position, whatever is the resting position on the upper surface, that is called equilibrium position. From that equilibrium position, the water molecules are executing in the up and down motion. Why these ripples are occurs? We have created some disturbance in this water medium. So same like that, in any medium, if we create some disturbance, due to the disturbance, there are some vibrations of the particles occurs. The disturbance in the medium is called as wave. The main characteristic of the wave here is particle doesn't move from one end to the another end. Only energy can transform from one end to another end. That means the particles are executing or vibrating from their mean position or equilibrium position. Okay. For example, this is the equilibrium position of the medium. This is we can take an as a axis. This is x-axis. That means this is the surface. This is the y-axis. Now we are observing the waves like this. Okay. That means if it is called as origin, from the mean position, the some of the particles are vibrating in the upward direction and some of the particles are vibrating in the downward direction. These are called as crest and this is called as trough. Now I would like to tell the definitions of crest and trough. Crest means the section of the wave that rises above the undisturbed position is called crest. The trough means the section which lies below the undisturbed position. Undisturbed position is nothing but trough. A wave consists of alternate crests and troughs. This is crest, this is trough, this is crest, this is trough. Like that, there are so many crests and troughs are exist. Now we have to be discuss about the amplitude and wavelength. Here the particle is displacing at the first maximum distance. Is it or not? Maximum. The maximum displacement is called as amplitude. The maximum displacement is called as amplitude. It can be denoted with the letter A also. The maximum displacement from their equilibrium position is called as displacement. Once again, this is the equilibrium position. From that equilibrium positions, the vibrations are coming like that. That's where the ripples or waves are forming. The maximum displacement is called as amplitude. This is the amplitude. This is the amplitude. This is crest. This is a trough. This is crest. This is trough. This is the crest. This is also a crest. The distance between the successive two crests is called as wavelength. The distance between the two successive crests is called as wavelength. The wavelength we can be denoted with letter lambda. Wavelength. Unit angstroms. Angstrom. Wavelength we may taken as distance between the two successive crests or distance between the two successive troughs, and we may taken as the length from the one complete cycle. That means from here to here. These points is also called as nodes, and also these points is called as antinode. So from here to here, from here to here also it can be taken as a wavelength lambda. That means from here to here it is lambda, then here to here it is also lambda. That's why this position is equals to 2 lambda position. Do you understand what I am saying? One complete cycle is wavelength lambda, and this is also one complete crest and trough. Okay, so this is lambda plus lambda. That means r from the origin, this position is 2 lambda. And if we consider this one as a 0, if it is a lambda, this position is called as lambda by 2 position. This position is called as lambda by 2 position. Few more definitions we should know to understand the interference and also the principle of superposition. Those are path difference and phase difference. Path difference, path, that means distance. Difference, path difference or phase and phase difference we will discuss now. Path difference means the difference between the length of two paths. The difference between the length of two paths. For example, this is the equilibrium position. This is the origin. From the origin, our wave is traveling like this. It has amplitude A and wavelength lambda. First wave started at the point origin. If its second wave itself started from the same position, so automatically those two are traveling like this. Now, is there any path difference exist? No. Both waves are started at the same point origin. That's why the path difference is 0. Path difference is 0. For example, this is the 0th position, this is the lambda position, this is the 2 lambda position, so on. Now our first wave started at the position origin and second wave started at the position lambda and traveling like this. Now tell me, is both the waves are started at the same position? No. The first wave is extra traveled. How much extra traveled? Lambda distance extra traveled. Therefore the path difference here is lambda. For example, this is the origin, this is the lambda, it is lambda by 2. This position is lambda by 2. First wave started from the origin here, traveling like this. Another wave started at the position lambda by 2 and traveling like this. Then here the path difference is lambda by 2. I think you understood the difference between the path difference. And we have to be discussed about the phase difference. Phase. Suppose if you see here both the waves, the first wave is traveling like this, second wave is also traveling like this. First wave is in the upward direction or clockwise direction, the second wave is also in the same direction. Both are overlapping. That means both the crests are overlapping and both the troughs are overlapping. Okay, then there is no path phase difference between those two waves. Why? Because those two are in same plane. But if you take here, the first wave itself traveling in the opposite direction or negative y direction or anti-clockwise direction, the second wave itself starting or traveling in the clockwise direction or upward direction. That means these two are in out of phase. This change is can be called as, the difference is called as phase difference. That means here the phase difference is half circle. Half circle means 180 degrees. It may denoted with pi. But if you see here, the phase difference here is 0. Phase difference is 0. If the phase difference is pi or 180 degrees, the waves are traveling in the opposite direction. If the phase difference is 0, 2 pi means 360 degrees, 4 pi, like that. The first wave of the crest is coincide with the second wave of the crest, and first wave of the trough is coincide with the second wave of the trough. These are the important points you should remember to understand the principle of superposition. Okay? In our next class, we will discuss the principle of superposition. Thank you. This is Guna. Please do subscribe my channel. Thank you.